This class should be a revision. Just 35 minutes, we are through. I will run with the speed of light. Yeah? So once it's biology, we are free to run. Don't copy. We are going to review endocrine system. We are going to do what? You know why I called it a review? We talk about for animals and plants. We just a short review. We run with the speed of light. You don't need to write. Eh? Because I will slap you if you write. Okay. I believe endocrine system is not a new topic to us. Is it very new to you? Eh? I wish at the end of I'm checking my phone, I should have a quiz there. So at the end of the class, we come online. I'll share the link. Then you write the quiz. Eh? You don't have phone? Don't worry. Let's not distract. Should I fire? Hmm? Which one broke actually? I think it may be anemia. Hey. You see the media people, they are spoiled our pointer. Okay. Let's start with like this. Anytime we talk about endocrine system, of course, you know we are talking about hormones. True or false? And in order for us to maintain homeostasis in life, you know what is homeostasis? Homeostasis is what? The regulation of the internal environment of the body. In order for us to achieve this, we know that the endocrine system have a major role to play. True or false? So for us to achieve homeostasis, the endocrine system will work in pari passu with the nervous system to achieve that. The other things that will join, they work synchronously, they work hand in hand. So the endocrine system is telling us about group of glands. Group of what? Glands and capillaries that helps that facilitates the diffusion of hormone into the bloodstream. What did I say? It consists of what? Group of what? Okay, leave it like this. I know that's sympathy. It consists of group of what? Glands and what? Capillaries that facilitates the diffusion of hormone into the bloodstream. So class, what is endocrine system? And listen, I not say you should read what you have on your screen. Read the one I'm saying. If I appear there, if your neighbor is sleeping, tell the person is on go first in class. I'll disturb that person. I said that endocrine system consists of what? Group of what? Glands and the what? Capillaries that facilitates, that does what? Facilitates the diffusion of hormones into the bloodstream. Taking. I don't say you should write, just know it. So I say it extemporaneously. 1, 2, ready, go. Second, wait, there's one secretary writing. Are you under attack? Just listen. All right, 1, 2, ready, go. Consists of what? Into the what? Bloodstream. You see, very simple. And what is a hormone? A hormone is a chemical messenger. A hormone is what? A chemical messenger produced by an endocrine organ, poured directly into the bloodstream, where they are carried to their target organ, where they perform a specified function. All right, class, let's go. A hormone is what? A chemical messenger produced by an endocrine organ, poured where? Directly into the bloodstream and carried where? And carried to their target organ, where they perform a specific function. So, but We have 3 types of glands. Help me. Glands. Give me the other slide that talked about glands. Let them see what is a gland. The other slide in form of PDF. A gland. I read. Uh-huh. Oh, yeah, tell me, what is a gland? Just define a gland for me. For use in the body or for what? Discharge into the surrounding. Uh-huh. There are 3 types of glands. The what? Endocrine. And okay. Can you give me example of endocrine organ? Just leave the slide there. I know you know it. Just tell me. The heart. The heart is a minor endocrine organ. We want to list the major ones. Oh yeah? All those ones are minor. Oh, don't worry, I know. I thought we... Now, if we don't call it endocrine, what do we call it? Say ductless. Say ductless. Ductless. This is ductless. It doesn't have a particular duct. Their content is being found in the blood. Okay, example, I know. Let's start from the self to the kuda, from the head to the... Okay, is this blocking somebody? You know, I like this. Oh yeah, number 1 is what? Say pituitary. Just pituitary, just for you to get the spelling. Oh yeah, self. I have after pituitary. Let's move major ones. Eh? Somebody is saying hypothalamus. Tell that person receive sense. Hypothalamus. In fact, let me write it somewhere. Hypothalamus. Hypothalamus is a neuroendocrine organ. What did I say? Yes. In fact, it is the hypothalamus that unifies the endocrine system and the nervous system. The hypothalamus produces hormone, but at this level, we are not permitted to call it an endocrine organ. Is that okay? Yes, but it is it. You can better refer it as part of the brain, but never call it at this level an endocrine organ. So let's start pituitary. After pituitary, we should have the thyroid. Oh yeah, next, after the thyroid, parathyroid. Don't write secretary. Don't copy that in. Don't copy that in. After this, we are going down. Parathyroid. Major ones. Adrenal. Add what? Renal gland. Add. After adrenal, you go to the what? Gonad. So, what about the exocrine? Can we say what's like that? The exocrine, they have not outside, not endo, and no. Exocrine has a particular duct. I said it has what? Its content, let's see this slide. Its content is being produced in a duct. Like we have the salivary duct. Help here? The lacrimal duct. What again? The sweat duct. What do they produce? Sweat duct, you see, when you go to the sweat duct, what are you going to find there? Sweat. When you go to the lacrimal duct, what do you see there? Lacrimal now. Tears. When you go to the salivary duct, what are you going to see? You see it produces something. But the something is being poured into a cup or into what? A duct. Unlike the endocrine, there's nowhere you have. Do you know your hormones? You know there's a hormone called growth hormone. Is there anywhere I'll go to your body and I'll fetch growth hormone? Now, where will I see growth hormone or estrogen? I have to do a hormonal assay. I will use your blood. Do you get? Go to the lab and find out the percentage of hormone in that blood. No, where did I see that hormone? In the blood. There's no particular place you see it. That is why it is known as what? Duct what? Legs. But this one has a particular duct. Of course, if you come to the sweat duct, you are going to see the sweat. Thank you. Let's see the examples. Exocrine glands that secrete their products into ducts. Number one is what? Up. Number two. Number three. What are you going to see in the mammary glands? You say, Mama, they are going to see what? Breast milk. Okay. I don't know what is wrong with that. Now the next is heterocrine. Say heterocrine. So heterocrine should combine this function. Yes. Example, the pancreas. Example what? So what does it mean? That the pancreas has an endocrine function and the pancreas also have what? So class again. What is a gland? A gland is what? For use in the what? Or for what? Discharge in each surrounding. How many types of glands do we have? Number one. And exo and what? Hetero. Now I say, which organ of your body produces hormone as well as secretes hormone? Okay, which organ of your body has an endocrine as well as an exocrine function? The pancreas. Okay, that's nice. Now remember we said that for us to maintain homeostasis, which two systems need to work in pari passu? The nervous and the what? So we are going to just do a small table that will help us differentiate between nervous control, nervous, and what? Okay, let me start with endo. Endo and nervous. If you can give me a good marker, I will appreciate that. Nervous and endocrine control. Number one, this guy evokes. I write this one. Right. I think you can now write now. This evokes a long lasting effect. A long lasting effect. Why this one evokes a short-lived effect. The actions of endocrine system are widespread. They are widespread. Why? For nervous coordinate, it is localized. Number three, this guy uses mainly chemical messenger known as hormone. Uses chemical messenger known as hormone. Why this guy uses mainly electrical messenger. Known as neuron, and also uses chemical messenger known as neurotransmitter. At the synapse. Number 4, this guy can be seen in plants and animal. Why this guy can only be seen in animal? We mustn't copy. Just listen. Let's explain this. Madedego. Oh, yeah, read number 1. Once you're ready, go. Endocrine effect evokes a long-lasting effect. Why for nervous, it is what? Short-lived. Number 2, it is widespread. Why for nervous, it is localized. Okay, let's explain 1 and 2. If anything happens to you and it have to do with the hormone, that thing always have a long-lasting effect. It always have what? A long-lasting effect. Any hormonal change affects your entire body. Most times it lasts for a very long time. But once it have to do with nervous system or nervous coordination, if I pinch you, will the effect stay long? Just for a short time, you start feeling the pain. But if it have to do with hormone, you have to take time. Just small hormonal imbalance. You did not see your period for 3 months. And they are now on NSVP. Just small hormone, something that changed. Now imagine, you're a young girl growing towards maturity. Yes, you have not reached your majority. You watched yourself in your mirror. 12, 13, you're approaching 14, 15, 16. You started seeing some developmental changes. Some things started propping up. And that is why you can now shake what your mama gave to you. Actually, your mama gave it to you. That thing have been inside you when you were in utero. You see, that hormone has been there. But it is waiting patiently for the right time to take action, to pop out. It has been there. That estrogen, that progesterone causing you that thing, those things have been there for a very long time. Do you get? So most actions, most thing about hormone is long lasting. So that is why, as a young lady, when those things want to deceive you, you say you are just simple a hormonal response. You are just simple what? A hormonal response. Rest. Now, go to widespread. Most times endocrine, it affects the entire body. It affects your mood. It affects your habit. But once it have to do with nervous system, it is localized. Let's say a dentist wants to uproot your tooth, it has a fault. The dentist might not need to give you a general anesthesia. He might just go to the root of the teeth and what? Inject you. That is called what? Local what? Anesthesia. That's localized space. If they want to operate on this side of your body, they can localize it. Because it have to do with nervous coordination. Now, of course, we know that endocrine system uses chemical messengers. What is the name of the chemical messenger? So, class, define hormone for me. 1, 2, ready, go. A hormone is what? Produced by? Poured? and carried to where? A target organ. All right, for the last time, define a hormone for me. Those guys at the back, echo your voice. 1, 2, ready, go. Uh-huh. You see that a hormone is a vector quantity. Only a site of production. Only a target organ. Hormone can't just work anywhere. This particular hormone know that it is my work to do this. Yes, I'm in this girl's blood, but it have not reached. She has not reached 16. That is when I will act. They know their timing. They work like key. They know that this is the padlock I should unlock. Is that okay? So listen, I said a hormone have what? Sites of production and what? Target organ. Now check nervous coordinates. It uses mainly electrical messenger. Check anything that have to do with nervous system. What is the functional unit of the nervous system? The neuron. So it uses this. But it also uses chemical messenger. A place where two neurons meet is called what? Yes, two neurons meet in a place called synapse. Not synapse. It is called what? Synapse. And in that space, they don't touch each other. They don't what? There's a potential space there known as the synaptic cleft. So how will a neuron transmit a message from its body to another neuron? It is going to, at the point of the synapse, it will be converted to a neurotransmitter, which is a chemical messenger. But the word is that nervous system uses mainly electrical means of transmission. These are the differences. But somebody should now tell me what are the similarity, or what is the cardinal similarity between endocrine and nervous? They do what? Check now. They are both in animal. And take it. Both of them uses chemical messenger. That is the cardinal similarity. Now, what is the chemical messenger used by the endocrine system? What is the name of the one used by the nervous system? Awesome, not synapse. Neuro what? Transmitter. Okay. Should I clean? Let's continue. Remember, we said for us to achieve homeostasis, that the nervous system should work in pari passu with what? The endocrine system. Homeostasis, regulation of the internal environment of the body. And I see somebody asking you, and that somebody is Jam. I told them the question should be between question 20 and 30. 2025. But you will not write it because you get admission this year. Do you know what they will ask them? Which of these is a homeostatic response? Do you know what the homeostatic response is? Okay. I said, in order for us to maintain homeostasis, these two systems must work hand in hand. Let's explain something. If we have a hot weather, and this is your skin, and this is the blood vessel, we have a cold weather, this is your skin. Okay, hot. Let me go up. This is the blood vessel. So tell me, what happens to you in cold weather? That time you travel to the UK. to one of the European countries, what happened to you then? Say during the cold weather, you at times you experience a goosebumps. Those goosebumps are hemostatic response that will happen in order for you to achieve homeostasis. Now, during the cold weather, you will see that this is the blood vessel. Now, this blood vessel will dilate. Is it constrict? We constrict. We what? Constrict. And when it's constrict, it will move away from the surface of the skin. It's constrict. It moves away from the surface of the skin. So when this happens, the sweat pores will close. They will close. They will close. The erectopili muscles will cause the hair shaft to be erect. And you'll now be doing Oyinatsuge. And the devil will not tell you that day is weather for two. Tell that devil is weather for tea. So when it happens, just go and take tea. So why would this thing happen? In order for you to what? Conserve heat. You don't need to lose heat. In order for you to conserve heat, this thing will dilate, it will constrict, move away from the surface of the skin. All right, but see what happens in hot season. Media help us. In hot season, in hot weather, the blood vessel will what? Dilate. It will expand and come close to the surface of the skin. The sweat pores will what? Open. And the hairs will be bent like this. Hot season. When these two are touching themselves, what do you think is happening here? Friction. Friction generates heat. Friction what? Generates heat. Now listen. When your sweat comes out, when the sweat comes out and touches the surface of your skin, there's one thing you learned in physics about evaporation and boiling. What is different between evaporation and boiling? They told you that evaporation happens at all temperature, while what? Boiling happens at a specific. What is the boiling temperature of water? Celsius or Fahrenheit? Celsius. But at what temperature will water evaporate? At all temperature. At what? All temperature. Evaporation happens at all temperature. And we know that increase in surface area increases what? Evaporation. So as a girl, if you expose everything, what are you going to do? You evaporate. You should close your surface area to avoid what? Evaporation. Now, when this evaporation happens, imagine you are running. You are an athlete. Running, you see me. And you started sweating. Within seconds, your body will feel okay because the sweat will evaporate and it will take its latent heat of vaporization from your body. When it drives the latent heat of vaporization from your body, there will be a resultant cooling effect. There will be what? A resultant cooling effect. Now, when you are feeling heat, let me use that word heat. So, let's use it. What do you do if you're alone in the room? You what? Open everywhere. Expose everything. Up here? You are increasing the what? Surface area for evaporation to take place. And when the thing persists, what are you going to do? You rush to the bathroom and what? You pour water on your body. When you pour that water, you don't need to dry the water. Is that okay? Now, so that the water will evaporate, where will the water take the latent heat of vaporization? From your body. So as it takes it, there will be a resultant cooling effect. You have a pyretic patient. One neguma and fever. So what are you going to do? Will you go and wear that your sister thick blanket? No. If the temperature is high, expose the patient. You expose her. If it persists, carry tepid water. Carry what? Not cold water. Just tepid, lukewarm. You are neither cold nor hot. I will spill you out of my mouth. Just take that one. Sponge her. What will happen after that? The water will evaporate. Where will it drive the latent heat of vaporization? And those people at the back, where will it drive it? It will drive it from the body. So as the evaporation takes place, the temperature will come down to normal or near normal. And I always ask nursing students, but I know JAMB can be somehow, they might just bring it out for you in exam. But I tell them, mind the topic you are writing. If it is physics, no. If it is biology, no, because two of them, they don't have the same answer in that context. Now, why will your doctor dab your skin with volatile ether or methylated spirit prior to injection procedure? Why will your doctor, what am I teaching now? Biology. So answer me as a biology student. Why will the doctor, why will the nurse, why will the med lab scientist dab your skin with volatile ether or methylated spirit? Because uncle is teaching biology. The answer is to kill microorganism. That is the answer. Oboya. Because now listen, injection is an invasive procedure. Invasive procedure is any procedure that will compromise the integrity of your skin. Anything that can pierce its blood or water, anything that will break the integrity of it is an invasive procedure. So they don't need to introduce microorganisms to your body. They need to clean the surface of your body with this methylated spirit, because at times they are the bactericidal or bacteriostatic. Is that okay? But if we are teaching physics and you go to, I don't know whether it's page 253, that place they drew vacuum flask. M.W. Anyakoa said in black and white, doctors or nurses dab your skin with volatile ether or methylated spirits before injection in order to cause, say, numbness. Say numbness. Yes. What is numbness? Reduce sensitivity to pain. Say reduce sensitivity to pain. Say methylated spirit once if you pour methylated spirit on skin, what will happen? Tell me. There will be a cooling effect there. Okay? Aqua may evaporate. Kebe the latent heat of vaporization from your body. So after that, it will lose a needle. Will it pain you much? No. It will reduce the pain. The truth is that it will reduce the pain. Because the surface of the skin has been numbed. Okay. We debated there and I was in school in the hospital. If it is not the reason, I don't know if we have nursing mothers here. You go to health centers for immunization. And let's say after being delivered of a baby. Say women, do they deliver baby? No, you are being delivered what? Of a baby. They are being delivered of their baby. This will come out in your English. And they say, tell your neighbor, make sure you don't pour. Yes, I see that question now. Ada's mother was delivered of a bouncing baby boy. She did not deliver. Take note. Let's return to status quo ante. And you now went for that first time for BCG. No, sir, with a methylated spirit, you know that the skin is still fragile. Or maintain now 1 week or course or something else. So what will the nurse use? I worked as a nurse. I told you now. When I worked in Institute of Child Health, what would you use to clean the surface of that skin? You are going to use cold water. You are going to use what? Cold hair. Why you them? No, why you them? You use cold water. Put it. If you know anything about immunization is the cold chain system. So seeing ice packs, now you will hear feature the water. Now, what is the purpose of that cold water? To do what? To cause can we reduce sensitivity to pain? So in cold weather, in hot weather, after sweating, what comes next? Comes what? Cooling. After sweating comes what? Cooling. But remember, in cold weather, you need to conserve your what? You need to what? Yes, you need to conserve it. Because you need to conserve heat. These guys will close. So, in case you go digging use Zoya. But I love God. Because God took for the guys. God helped us. God know that our egg will be boiling and brought it outside. All those things, God understands homeostasis. All man a very hot season, the egg might what? Boil. Or say, no, let us bring it what? Outside. Okay, so I think we listed the major endocrine organ. Number one, do we list the pituitary gland? Okay, let's dissect it. I think very few minutes remaining. Few. Let's dissect it now. Don't worry, we'll finish now. Pituitary. Okay, what is another name for the pituitary gland? The pituitary gland is known as the hypophysis. Say hypophysis. Say hypophysis. Yes. You know, we have thalamus here. Then hypothalamus. Then this is the hypophysis. 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 The pituitary gland is divided into two, but it is three. But at this level, we work with what? Two. We have the anterior. We have the what? Anterior pituitary. Opposite of anterior is what? Posterior. We also have the intermediate. But the intermediate, we don't need to study it here. Okay. The anterior pituitary is also known as the adeno. Say adeno. Adenohypophysis. Adenohypophysis. The posterior is known as the neurohypophysis. We might not go into the etymology of this. Your exam don't require much. Of course, you know that the pituitary gland is known as the what? The master gland. Reason: the pituitary gland controls other endocrine organ. That is why it is known as the master gland. It has two basic divisions, the anterior and the what? Posterior. Of course, you should know your anatomical terms. Anybody in your front as you are seated in class is your anterior neighbor. Touch your anterior neighbor, please. Let me see. Your anterior. I'm your anterior neighbor now. Who is your posterior neighbor? The person at your back. Who is your right lateral neighbor? Lateral is side. Lateral venation. Lateral is side. Right lateral. Left lateral. Who is your superior neighbor? Superior. Above. Who is your inferior? Inferior. The devil. Who is your posterior? That's all those girls that went to HRC and quiz. Every day, uncle, Konim. Tell us this is your inferior neighbor. Open in on a center bunk. Tell us. Describe for us. Let's know the type of neighbor. Now, the anterior pituitary. That guy is blessed. What did I say? When you look at the pituitary gland, can I see the pituitary gland on the screen? The first one you will see, because the pituitary gland is somewhere like this. I should extend this. Now, if I'm looking at this edge, this is my anterior. This is the intermediate. This is the posterior. Are you listening? Now, listen. I told you that the anterior pituitary is blessed. The anterior pituitary produces and stores hormone. It produces and what? Stores hormone. Oh yeah, let's list the hormones this guy can produce. This guy can produce GH. Let's use their short form. This guy can produce TSH. This guy can produce and store TSH PRL. This guy can produce and store ACTH. This guy can produce and store FSH. This guy can produce and store LH. LH plus FSH plus LH is equals what? Gonadotrophin equals what? Now you see that the anterior pituitary, what is the full meaning of GH? Say growth hormone. If you're a secretary, keep copying. Keep copying. I will send this slide to you in your WhatsApp group. Keep copying. Look at the board. Growth hormone. Say growth hormone. Thank you. Say thyroid stimulating hormone. Or you say prolactin. Say adrenocorticotrophic hormone. Okuntabi, let's say it again. It's not ayano. Adrenocorticotrophic hormone. Say it again. If your mouth is closed at the back, you're under attack. Eh? Those people at the back, say adrenocorticotrophic hormone. Don't be like that student that said, Uncle, is adrenocortico one. Now, this is follicle stimulating what? Hormone. This guy is luteinizing hormone. Two of them are gonadotrophins because they are produced at the... No, they are not produced. You see your brain. They are produced at the anterior pituitary. They work at the gonad. Where is their target organ? Gonad. I say, boy, gonad. No problem. Now, go to the posterior pituitary. This guy have problem. He doesn't produce hormone, but he stores. What did I say? He doesn't produce, but he's what? Stores. He stores two types of hormone we know. The anti-diuretic hormone. Say anti-diuretic or anti-diuretic in company boy. That is ADH. What is the nickname for this hormone? Say vasopressin. You see our village people, they will not catch us. Say vasopressin. Say vasopressin. The thing, don't worry, we'll talk about how we presses the vessel. Now, the second one is oxytocin. You see these two hormones, they are deadly. I will tell you what they do. Antidiuretic hormone and what? Oh? Where are they produced to? Tell your neighbor, sense is what you need. Listen, I told you that antidiuretic and oxytocin, they are stored here. They are done what? Oh? They are not produced here. They are actually produced in the paraoptic and the paraventricular nucleus of the hypothalamus. Okay, don't worry again. Just where are they produced? Say just hypothalamus. Just say the nucleus in the hypothalamus. That is where they are produced. So when they are produced there, they can sit on the mojo. Media, show us this guy. Show us this guy. Show us this guy. Show us this guy. Now, after the production, they will be stored there. Okay, you see these two? Now, see. Now, check your screen. Check your screen now. This is the pituitary gland. Can you see the anterior? Antibus, okay? Posterior, nazo. Now, see this strand. If you are the neurosecretory neuron, they did not tell you the name, but you don't need to know the name. But I know the name, and the name will not come out. Do you get? This is where oxytocin and ADH is produced. They will now come here and be stored. I'll tell you what they do when the time reach. But you see these guys here, where are they produced? Where are they stored though? Anterior. After talking about this man, we'll go home. Growth hormone. As the name implies, as the word too. In fact, anytime you are studying about hormone, you only need to know a few things. You don't need many things. All you need to know, say name of the hormone. Name, number one. A. B. Site of production. Site of production. Say site of production. You need to know this, even if you don't know anything. C, know the target organ. Know the where. D, know the function of the hormone. Know the what too. And finally, know the problem associated with oversecretion. Oversecretion and underwater of that hormone. Imaya, you are now a consultant endocrinologist at your level. Just this, any hormone, you just know this thing. Now, you see this guy now. Now, what is the name? You see? Now, where is the site of production? Kebane produce here. Anterior pituitary. Kedebe pituitary gland, no. I was with my friend. I've told you, sorry. And Frank Edo called from Who Wants to Be a Millionaire. They asked a question. I think, yeah, that should be the pituitary gland. The pituitary gland is located in which region of the body? Head region, neck region, abdominal region, thoracic region. And my friend, we should be in second year then. The friend called her from Who Wants to Be a Millionaire. And that question earned the girl 1 M. You see, if they call you now and ask you which region is pituitary gland, he said, now, women not thoracic or now, but go outside that, go now. No. It is in the what? Pituitary, non again, head. Actually, the pituitary gland is located in the hypophyseal fossa or the sella tossica of a bone called the sphenoid bone. Of a bone called the what? The sphenoid bone with depression. The sphenoid bone with again the depression. And in biology, what do we call depression? Fossa. Say fossa. Indentation. Fossa. Now, the fossa of the bone, sphenoid bone is one of the cranial bones that looks like a bat. Afianain. Also. Now, that bat-shaped bone, that was sphenoid bone with depression. The depression, this gentleman, I wish I can see a better diagram there, if we have any, but I know we don't have it. No, so Eba Keta. Eba. This is the yard. Eba Kono. So, Kaiba is no. Ono na degene. Hypophyseal fossa. The name is hypophysics. The name is what? Hypophysics. Now, what is hypophyseal fossa? Hole for the hypophysics. So, biology is simple. So, where can you see the pituitary gland? The hypophyseal fossa of what bone? Sphenoid bone. But if you don't call it hypophyseal fossa, it was a sella tossica. But that thing can never come out in any exam. You're not writing PTS. You're not in school of nursing. The one that will come out is this thing we are doing. And that is growth hormone. Where is the site of production? Co-camp. Site of production is where? Anterior part of the world. You'll be spelling nonsense. Okay, where is the target organ? Because every hormone has a target organ. It's a vector, not a scalar. True or false? Thank you. Now, this growth hormone, every part of your body needs growth. Your eye, your tooth, your nose, everywhere needs growth. So where is the target organ? All tissues of the body. Say all tissues of the body. All cells, tissue, organ, everywhere, including every secret place in your body, needs growth. And growth hormone will act everywhere. So each target organ has no bound. Function. As the name implies, do you need to be told? Do you know more than me? It helps to stimulate what? The growth of long bones. And this hormone, media, slide, please. The PDF version of the slide. This hormone actually helps us in carbohydrate metabolism. It helps us in protein metabolism. And it helps us in fat and oil metabolism. Of course, you know what is metabolism. You may have metabolism. Don't worry. Now. Let's go to, okay, let's see the slide. Let's walk the slide. Next. Just 2 minutes. Okay, next. Read. Can we read? Want to read? Go. Action of growth hormone. We are in the function now. No, go back. There's something we should see before this. Anterior pituitary. Wow, nothing. But go there. Oh yeah. Read 1, 2, ready, go. I read again. Somatomedines. Okay. Now, before growth hormone, we ask, oh, we're a mediator. What is the name of the mediator? Somatomedins. But I'm sure it will not come out. Next slide, please. Effects of protein and what? Effect on protein. I read 1, 2, ready, go. Effects of protein and mineral metabolism. On protein metabolism. Growth hormone is protein anabolic hormone. On mineral metabolism. Increased calcium absorption from GIT. Increased sodium, potassium, calcium, and phosphorus excretion from kidney. No. Leave those ones. They have major clinical colorates. Metabolism is divided into how many parts? A building of parts called what? Anabolism. And the destructive part called what? Catabolism. What is the other one? Amphibolism. Say amphibolism. Yeah, amphibolism combines ana and kata. Next slide, please. That's the same thing. Next slide. Let's see. Next, please. Number 3. Effects of read 1 to read, go. Now, you see, I want you to know that growth hormone, diabetogenic means it can cause what? Yes, it breaks down carbohydrates into its monomeric unit. What is the monomeric unit? Also not starch, but monomeric unit of carbohydrates. Glucose, the absorbable form. So if growth hormone, that means if it can act on carbohydrates, it helps in carbohydrate metabolism. Of course, when it metabolizes, it will break it down to its what? Monomeric unit. And what is the monomeric unit? Glucose. That means if it acts too much, it can cause diabetes. Let's continue. On fat. Next slide. Next slide. Okay, let me explain what they have there. We're almost through. Before you release growth hormone, there must be a request. And what causes the release of growth hormone is growth hormone releasing hormone. Say growth hormone releasing hormone. So if your body senses, but I will talk about that when we start talking about feedback mechanism. Okay, let's leave it. When we're talking about feedback mechanism and how it works, we talk about those releasing and inhibiting hormone. Because before you release growth hormone, there must be a releasing hormone. You don't just produce any hormone. A releasing hormone will cause it to be produced. And all the releasing and inhibiting hormones are produced in the hypothalamus. Let's say we need to produce growth hormone in your body. You are growing, and Almighty God, or see Jesus, Chiamaka wants to be a kaporo. There will be a meeting of all the hormones. And where they have their meeting is in the hypothalamus. The hypothalamus will summon all the hormones. Or say, I am in charge. I am a neuroendocrine organ. Habia. Or see, this girl will be a short girl. Let us send a messenger. Nobody is producing growth hormone. So a messenger called growth hormone releasing hormone will come. Or say, my Lord, send me. So the growth hormone releasing hormone will now come to the where? Anterior pituitary. You will now say, hey, anterior pituitary. Oga say, may you start producing growth hormone. She wants to be a kaporo. She wants to be. So anterior pituitary will say, wow, Jesus, Until people will start producing growth hormone. Growth hormone will be coming out, be acting, performing signs and wonders, and she will now want to be a giant. Hypothalamus is a sensor. Sensor, you say, come, we have too much growth hormone in this blood. If we leave this girl, her husband will reach her here. So the hypothalamus we call Ima Oyo Gesendi growth releasing inhibiting hormone or just growth inhibiting hormone. Is it not the somatostatin? Yes. It's an inhibiting hormone, somatostatin. Or send there, you say, Biko, you run anterior pituitary. Tell anterior pituitary, no more sense. He should stop producing growth hormone before the husband leaves this girl. Anterior pituitary will not say, okay, I've heard, we are not producing again. Anterior pituitary will not produce again. And that time, you are like this. Hypothalamus will see it again and say, what is wrong with this guy? Now, hypothalamus will do what? Call a meeting. Konyo get send growth releasing what? Hormone. Okay? Kebo gaga. Eh? Anterior what? Okay, back. Okay, me. It will do what? Oh? Thank you. Now, oh God, before we say finally, what is the effect? I want you to see it on that screen. What is the effect of, don't worry, I trust my media. They will restore it now. What is the effect of oversecretion of growth hormone in children? Gigantism or what? Oh, giantism. In adults, acromegaly. The person bone will not grow in length because when go closure of the epiphyseal cartilages, the growth will not grow in breadth, in width. Onya amago like that confession. I'll show you a patient suffering from acromegaly. I have it. Then, what is the effect of undersecretion of growth hormone in children? Eh? You said what? Dwarfism. Dwarfism. Stop creating word. Okay. Now, tell me, what is the effect of under secretion of growth hormone in adults? The adult is tochago. What's cretinism? No. Cretinism is a profound iodine deficiency in children associated with mental retardation. As in cretinism, beginning, what profound? Cretinism is a congenital iodine deficiency in children associated with profound mental retardation. So the answer is not cretinism. The answer is not what? Cretinism. Adult to toche or stop you produce growth hormone physically. Amarami Oga cause. Okay, check and work here. They will not ask you that one. Media, please. Show me that image. Okay, let's answer these two questions here before we share the grace in fellowship. Okay. Sir, please. If they are operating on your left or right, and it is not on the nervous system aspect, must you get full anesthesia? You get anesthesiology. There are indicators to know whether to recommend for. Next slide, please. Let's see. Who is this person? Yes, overproduction of GH, tall stature, bilateral gynecomastia. What is gynecomastia? Yes, gyna now. Gynecomastia. So those guys. Next slide, please. I read 1, 2, ready, go. Is due to what? in adulthood. Okay, next slide. Your man. Next slide. Bye. Have a nice day. Now, before we share the grace,